how to draw these angles. Go ahead and do your best to draw these angles for your warm-up. All right, so what does, okay, somebody tell me what does a 45-degree angle look like? Dylan? It is acute, and it's kind of like a 90-degree, it's like right in the middle, right? Okay, 90-degree obviously is, you've got a right angle. Okay, what does a 180-degree angle look like? Straight line, right? Okay, now it can be, even if you turn it sideways, this is still a straight line, right? Okay, so a 180-degree angle can be, as long as it's a straight line. And then 150, okay, it's going to be a little bit less, maybe something like that, okay? You're not going to be able to draw these exactly, or you might, but as long as you have kind of an idea, okay? And if a pitching machine throws a softball up at an angle of 11 degrees, okay, draw this angle. Well, if it's a pitching machine, it's kind of shooting it straight, but it's going to go up at 11 degrees. Is that a lot? No. If it went up at like 45 degrees, it's going to go way over people's heads, right? Okay, so 11 degrees is just a little bit, okay? So you can kind of look at, hold on a second. Okay, well, there we go. So you can kind of see, well, okay, did you see your responses? All right, good job. All right. Okay, so first thing, a lot of what we're going to learn. Does anybody know what vertical angles are? Okay, several of you went like this. You automatically think they're going straight up and down, okay? Great guess, but no. Okay. Does anybody know what adjacent angles are? Okay. Well, we'll go over all of that stuff, okay? You can watch this short little video. Right? Okay, now, if you happen to look at this, there are, not necessarily at the track, but you see all these white parts? Okay, these white parts that are supporting the structure? There are all kind of angles happening there, okay? And those have to be very, very precise, don't they? Okay, or in other words, this is going to be, otherwise that ride is going to be dangerous and it's not going to work correctly, okay? All right. So some of the stuff vocabulary-wise that we're going to learn about today. Okay, an acute angle, everybody knows what an acute angle is, right? Okay. An acute angle is less than 90 degrees, greater than 1 degree. So if I had, for example, a 53-degree angle, that would be considered acute, okay? Adjacent. Now, what adjacent means, okay, are some angles, two or more angles that share a side. Okay, so if I had like an angle here and another angle right here, they share a side. They're right next to each other. Adjacent is basically what that means, okay? Congruent. Does anybody know what congruent means? What does congruent mean? Who has heard the term congruent before? Okay, do you guys remember what that means? Okay, it means the same, okay? If an angle is congruent to another angle, that means they have the same measure, okay? So if I have an angle that's 35 degrees and another angle that is congruent to that, what's the angle measure? 35 degrees, okay? Obtuse, what's an obtuse angle? Greater than 90 degrees, less than 180, okay? So like an angle like that would be an obtuse angle, okay? Right angle is exactly what? Right angle is exactly what? 90 degrees, exactly 90 degrees. Now, a straight angle is the exact same thing as a 180-degree angle, okay? So it's often when you hear the term straight angle, it's also meaning 180 degrees. Make sense? Yeah. Okay. You don't have to write those down. Okay, that's fine. So let's take a look at some of these angles. All right. Remember, a vertex is where the two angles come together. Okay, so like on a clock, if this would be considered the vertex right here. Okay, so just looking at this angle, what kind of angle would this be? Acute. What kind of angle would this be? Right. Straight angle. Okay, even though it's going straight up and down, it's still a straight line. Okay, so that would be a straight angle. What kind of angle would this be? Obtuse, and this would be a right. What about this one? It's a zero angle. There is no angle there, right? Okay? All right. Okay, now sometimes you'll see when we refer to a specific angle, okay, you'll see like this little signal right here, okay? Now this says an angle named, thing says an angle named angle XYZ is red angle XYZ. Now the reason we call it XYZ, okay, this goes from X to Y to Z. Notice the middle, okay, the middle is what we call the vertex. That's where that middle point is. So it goes like X, Y, Z. What could this also be called? Could it be called ZYX? Could be. It could also just be called angle Y if it's referring to the vertex. Okay, does that make sense? Okay. Okay, just like I said, the angle can be named by one letter called the vertex. So we can call this angle S or angle 3. Does that make sense? If I was talking about this entire thing, what could I say? Could I say angle RTS?
Yeah.
Why could I not say that? Because T is not the what? The vertex. That middle number middle letter or number has to be the vertex. So if I could say TSR or I could say what? RST. Okay, good. Yes, ma'am.
Need to attend this, please?
Yes, ma'am. Sorry.
Thank you.
Okay, we're back. All right, so if I have an angle that looks like this, okay, could I call this angle RTS?
Nope.
No, and that's not correct because T does not represent the vertex. Good. Okay, so if I was asking you to name this angle for this example, okay, what are some ways, what are 4 ways I can name this angle? Okay, what's one way? Angle 1. What's another one? Come on, class, what's another one?
Y.
Angle Y. Okay, what's another one?
Angle I.
Angle XYZ or angle ZYX. Good. If I use those points in addition, I have to include this Y or the vertex in the middle. Okay, good. All right. So we does that make sense to everybody? All right. Okay, we don't need to spend time on that. That's easy stuff. Okay, now, when we talk about vertical and adjacent pairs, okay, vertical angles are angles that are formed on the opposite sides of an intersection, okay? So if, for example, I formed an intersection here, right, with these pins, okay? The opposite sides, like this angle and this angle, those are considered vertical angles, just like these two are vertical angles, okay? And the thing about vertical angles is they have the same measure, okay? So if I have a pair of intersecting lines, okay, kind of like this, okay, what's an angle that I have here? Could I have angle ACE? Would that be an angle? No, I could have angle AEC, right, or CEA, okay, and then angle BED or DEB, right? What's 2 more angles I have here? Dylan? BEC, and another one I have? DEA. Okay, there's actually several angles formed here, right? Okay, so when I have vertical angles, if I had a measure for angle BEC, let's say it was 120 degrees, okay? Remember what I just said about vertical angles. They are the same measure on opposite sides of an intersection. So if this is 120 degrees, what would this be? 120 degrees. If this was 60 degrees, what would this be? 60 degrees. Okay, good. Does that make sense? Okay. It says compare angle AEC and BED, just like AEC and BED. They are the same measure. Okay? Now, BEC and AED, they are also the same measure because they're the same angle. Now, what do you notice about, what about this thing right here? What is this? Somebody tell me, what is it? It's a straight angle. It's a line, which is a straight angle. So, if you think about it, okay, I have another line here, right? Okay. So I have 2 straight angles there. Okay. Then we have a vertical angle pair, okay, opposite sides of the same vertex. So if I have angle AEC, how does it relate to BED? AEC, BED. How do those relate? Same measure, okay? BEC would have the same as AED. They would have the same measure. And right now I'm not given any measures, but if I did have those measures, it would be pretty easy for me to tell what those are, right? Hey, whatever you guys are doing, I need you to stop. please. Okay, I'm trying to do this. All right. So we will continue with, okay. So the next thing, when we learn to identify vertical angles, okay? All right, two angles are vertical angles. They're opposite sides form. Vertical angles are congruent, meaning they have the same value or the same measure. So angle 1, if I had a value, what is it going to be the same as? Look up here. Angle 1 is going to be the same as what? And angle 2 is going to be the same as what? Angle 4. Okay. What do you notice about these two, by the way? These two angles, what are they formed along? What are they formed along? A straight line, okay? So if I had measures here, these two together, if they form a straight line, those two together, remember, what's the measure of a straight angle? 180 degrees. So if I had those two measures together, they should equal 180 degrees, right? Okay. All right, let's continue with this. All right, so these vertical angles that we have here. All right, what do you notice about this? There's more than just two lines, right? Do you think that changes anything? Okay. So if I have the measure of angle 1, what other angle do I also have? Angle 4. If I have angle 2, what do I also have? Angle 5. And if I have angle 3, I also have angle 6. Good. Those are all considered vertical angles. Now, there are lots of these things that are straight lines. There's actually several straight angles here. These three right here, what would those three angles add up to? 180 degrees because they are formed along a straight line. What about these three? What would those add up to? 180. What about these three? 180. Okay, does that make sense? Okay. All right. So the well, we already did this. We're good on that. Okay. So if we look at this intersection, can you tell me what angle pairs are congruent? Okay, we can identify the vertical angles here. Okay, what is angle 3 is vertical to angle what? 6. In other words, they're going to have the same measure. Angle 4, what's that going to be the same as? Angle 1 and angle 5 is congruent to or vertical to angle 2. Good. All right. Easy stuff. Okay, now when we're finding missing values, okay, it's easy to use vertical angles because they have the same value, okay? So if, for example, we can watch this real quick. All right, here we go. We'll start that over. All right.
Vertical angles are opposite angles formed by a pair of intersecting lines. Angle ABB and angle CED are vertical angles.
Okay, so let's take a look at this, guys. These two angles equal each other, right? So if I was to put an equal sign in the middle of them, okay, 75 equals 4x minus 5. Do you think I could use that to solve for x? I could, right? Because this equals this. What is that if I put an equal sign between those? What did I just form? A what? A two-step equation. And you know how to solve two-step equations, don't you? Okay? So you could use that to solve for x.
Write a congruency statement about the vertical angles. Vertical angles are always congruent. This means they have the same measure. Write an equation by substituting for each angle measure. The
Okay,
measure of
so this would be our equation, okay? Now, these parentheses, okay, we can't really do anything with those. Why? Because we don't know what is. We don't know what x is. Once we found out what x is, okay, we know that whatever this is going to equal what? 75. So we can treat this like an equation and solve for x so that we can figure out that these should both equal 75. Okay, does that make sense?
AEB is 75 degrees. The measure of angle CED is given by the expression 4x minus 5. The last step is to solve the equation to
Now, they might do this a little bit differently than what I've showed you, okay? They're not gonna mention the box, but what would go in the box here? The 4x, and then I would have what outside that box? A -5. So how would I get rid of that -5? You would add 5 on each side, which would leave me with 80 equals 4x, and then what would you do when you have 80 equals 4x? Divide each side by 4. And what would x equal? 20. Okay, now we'll see
find the
when they
value
solve
of x.
this.
The value of x is 20.
Yeah, see, they just solve it, okay? But you know how to solve it, right? Okay, so let's look at this one. If I'm going to find the value using vertical angles to find a missing angle. Okay, look at these two. Are these vertical? Are these two vertical angles? Yeah. Remember, what makes vertical angles vertical? They're on opposite sides of an intersection. So whatever, this side is 130 degrees, what does this side have to equal? These are the same thing. So when I write my equation, write your equation. Let's see if you get it right. Write your equation in your notes. And you should have in your notes 130 equals what? 2x plus 2. Now, can you solve that? Okay, go ahead and solve that. Okay. And you should get x equals 64. Okay. Now all we did was, this is the same type of equation. 2x plus 2 equals 130. Okay, we would have 2x in the box, subtract 2 from each side, 2x equals 128. Divide each side by 2, and x would equal 64. Okay? Does that make sense what we did for x there? It's pretty easy, right? Okay? All right. So take a look at this last example. Okay, and I want you to solve for x on this vertical intersection. Solve for x. Don't just do it in your head. You got to write an equation, please. Okay, how many of you have your equation written? Okay, somebody tell me, what did you write for your equation? Olivia, what did you write for your equation? How many of you guys have the same thing? Good, because those two are vertical angles. That means they have to equal each other, right? So 100 equals 2x plus 4. Okay, and what did you guys get when you solved for x? Cade? 48 degrees. Not 48 degrees, sorry. 48, because when you plug it in, you're going to get 100 degrees. All right? Okay, does that make sense how we do this? Does that make sense? Okay. Do we need to do any more examples of this? I think we're good. So let's look at adjacent angles. Remember, adjacent angles are next to each other and they share a side, right? Okay, so if I have two adjacent angles, okay, right next to each other, okay, tell me some adjacent angles here. What is angle 1 adjacent to? No, not vertical. What is angle 1 adjacent to? 2. It's also adjacent to what? 4. Okay, what is angle 3 adjacent to? Angle 2 and angle 4. Okay, do you understand what I mean by adjacent? They share a side. There's a difference between those and vertical. Okay, adjacent angles, okay, they are two angles that form a straight line. They are in this case, they're forming a straight line. So therefore, the two angles together, or 3 in this case, would equal 180. Okay, so what are the angles that are adjacent to 1? 6 and 2. Okay, what is angle 4? Is angle 4 adjacent? What is angle 4? Vertical. Good. Angle 4 is vertical to angle 1. Does that make sense? Okay. The ones that are adjacent are 6 and 2 because they share these sides, right? Okay. Oops. Sorry. I want to go back to that. All right. Let's go to the next. Okay. So when I use adjacent angles to find a missing value, it's the same kind of thing, except they don't equal each other like they do on vertical angles, okay? So we can watch this little short video real quick.
You can use adjacent angles to find an unknown value. Adjacent angles have a common vertex and a common side.
Okay, let's take a look at this. These two are adjacent, aren't they? Because they share this side, don't they? And they share this vertex. Now, does this equal this, though? They don't equal each other. These are not vertical angles. But if you notice, guys, from here to here, what is this whole thing? What is that thing? A straight angle. Therefore, what are the angles? What are the sum of those angles if it's a straight angle? What do they have to add up to? 180. So that means this plus this have to equal what? 180. Okay? So you can make your equation a little bit differently on this. Okay, it's going to look like, and we're just kind of jumping ahead here, 180 equals, what are the two angles you have? 5x plus what? Plus 115. Okay? And again, it's still just a two-step equation.
Angle AEB and angle BEC are adjacent angles. If two adjacent angles form a straight angle, then the sum of their measures is 180 degrees. Angle AEB and angle BEC form a straight angle. Write an equation by substituting for each angle measure. The measure of angle AEB is given by the expression 5x. The measure of angle BEC is 115 degrees.
What do you have here? What is this? Two-step equation, right? So what would go in the box here? 5x. What would be outside this box? Plus 115. And how would I get rid of that? Subtract 115 from here and from here. And then I would solve for x, wouldn't I?
The last step is to solve the equation to find the value of x. The value of x is 13.
Okay, and again, they just kind of jumped ahead by skipping all the steps. Okay, but if I look at this one, look at this example 5. Okay, tell me, what do these two equal? Do these equal 180? No. But what am I told down here? What does this say? This says the measure of what? Angle ABD equals 128. So from here to here to here equals what? 128. That means these two together have to equal what? Guys, look. From here to here to here. That's 128 degrees. That means this angle plus this angle equal what? 128. So what would my equation look like? 128 equals 5x plus 63. Is that just a two-step equation? Very easy, right? Does that make sense? Okay. All right, so what I want you to do is on page 401 in your books, okay, I want you to do numbers 1 through 8. Okay, page 401, 1 through 8 is your assignment.